A variable is the name we give to represent a piece of data. Let me give you an example. Say I want to draw a picture of a beach ball, a whole scene. I'm just going to call it beach ball. The problem is the computer doesn't know what a beach ball is, so we have to define it or tell the computer what beach ball means. So the first thing I do is write main equals drawing of beach ball. Now we need to figure out what elements comprise our scene. I know I want a beach ball with a stripe, some sand, and some sky. So I'm going to write beach ball equals stripe first because it goes on top of the ball next because it goes on top of the sand next because it goes on top of the sky. So your drawing is multiple layers, and whatever you put first is what shows up on top. If I were to put stripe at the end, you wouldn't see it because it would be behind all the other pictures. As a side note, the reason I named it ball instead of circle is because the computer already has a meaning for circle. It's already in its library. If you say circle, it knows what to do. I'm creating something new, so I need a new word. Now I'll list the variables in beach ball. We're going to define each variable, and I'll start by holding their place with the word blank. This just lets the computer know that we'll have a new variable and we'll define it later. If you don't write blank, you'll get an error message. This is how you would write the actual code for this picture. We're going to learn how to do that in a minute, but for now, using the template on the screen, plan your own drawing of something that has 3 or 4 elements in it. I'll give a few examples, then pause the video when you can see the template again. You made it to lesson 3. Good job. This lesson is where it gets fun because you're going to learn how to transform your shapes. You'll learn how to scale them, which means make them a different size, move them around the screen, rotate them, and change colors. So this is a fun one, and let's get started. Let's do a quick review of functions. We'll do an example and I'll talk you through it. Remember, a function is like a machine in which what you put in determines what comes out. Let's run a quick program and review the elements in it. So in your editor, type in main equals drawing of circle 5, and then we'll look at the parts. In this program, the function circle is like a machine that makes circles. The parameter is 5, the radius, so it's going to tell the circle machine what size of circle to make, and the thing that comes out is the drawing of a circle. Now let's change our picture with some transformation functions. To change the size, we're going to use a function called scaled. Scaled is the function that resizes your picture. The parameter is going to be the picture and then an x and a y variable. Those x and y variables mean how big you're going to make it on the x-axis and how big you're going to make it on the y-axis. For example, if I type in main equals drawing of scaled circle 5, the first parameter, 2, means I'm stretching it out 2 times on the x-axis. The next parameter is a 1, which means I'm stretching it out 1 time on the y-axis. And keep in mind, when you're timesing something, if I multiply something by 1, it stays the same. 3 times 1 is still 3. So if you scale something by 1, it just means you're not changing it at all. You're keeping it the exact same size. If you scale something by 2, it makes it double the size. Here's a visual demonstration of the concept. If my picture is the CodeWorld logo and I times it by 2 in the x-axis, it's going to stretch it out twice as big on the x-axis, and notice 1 on the y-axis, it stays the same. Then if I change it to 1/2, it's going to scale the CodeWorld logo to half the size on the x-axis, and the y-axis stays the same. If I scale it by -1, it just flips it around but stays the same size. If I scale it by -2 on the x-axis, it stretches it twice as long but flips it over. So scaling is like multiplication. If you scale it by 1, there's no change. If you scale it greater than 1, it stretches the shape larger. If it's a fraction, like you divide it by a half or 0 point something, then it shrinks it to go smaller. Scaling it by 0 means it's so small you can't even see. Just like if you're multiplying by 0, it means there's nothing. You don't want to scale by 0 because it'll disappear your x or y axis, whichever one you have it in. And negative numbers, flip it over. Now you're going to pause the video and just experiment, play around with scaling, change some of the numbers to fractions, make it twice as big, 3 times as big, just so you can get comfortable with that function. Let's move on to the next function. This next one is how you move things around. It's called the translated function. The word translated is the function, and you put the parentheses next to it where the parameter goes. The parameter is going to be the picture that you're using, the picture that you want to move around, and then the x is where you want to move it on the x-axis, and the y is where you want to move it on the y-axis. If I have a rectangle with a width of 2 and a height of 4 units, and I want to move it down and to the right, I would wrap it around with the function translated. So I'm going to put translated, open parenthesis, because I'm opening up the parameter. The picture is my rectangle 2, 4, and then I put a comma to denote that I'm going to write the x and y axis. And I'm going to move it 5 units to the right on the x-axis, and -5, which means 5 units down on the y-axis. Then I close my translated function with another parenthesis, and then I close my drawing of function with the black parenthesis that you can see. All right, here's a challenge for you. You're going to try to draw the circle on the screen in that exact location using the translated function. Pause the video if you need more time. Our next transformation is the rotated function, and this is the function we use to turn things in our program. To rotate things, we write the function rotated and then with an open and close parenthesis. And inside this parentheses, you put the parameter, which is going to be the picture and a comma, and then the angle. Let's talk about angles a little bit. An angle is made up of 2 rays that share the same endpoint. The common endpoint is called the vertex. Another way to think of an angle is as a section of a circle. A circle has 360 degrees. In CodeWorld, we start at 0 on the right, go counterclockwise, and end in the same place at 360 degrees. We measure the amount we want to turn our picture using the degrees in between. In this example, we rotated it 45 degrees. Let's try it out. Type in run main equals drawing of rotated rectangle 4, 2 with an angle of 45. Rectangle 4, 2 is my picture, which is the first parameter. Then you write a comma and write the angle you want to turn it to, which will rotate it counterclockwise. Sometimes you want to translate or move and rotate something. I've had many students confused when doing this, and I want to stress that it matters what order you do these things in. If you translate the item first, like so, then wrap it with the rotation function, you are rotating the translation and your picture might end up somewhere you didn't intend. But if you rotate the picture first, then translate it, you'll end up with the rotated picture exactly where you specify in the parameter. See if you can rotate a square. Remember that a square is a rectangle with equal sides. Pause the video and play with the angles, and resume when you figured it out. Did you get the challenge? Check your code to see if it matches this. Was the coordinate plane helpful? You can add a coordinate plane to your canvas anytime you like by adding an ampersand and a coordinate plane with the P capitalized. Let's do a review challenge. See if you can draw these huge letters. I should note that the font may look different on your computer. That's okay. Pause the video until you have it. Did you get it? Here's the code to make your text 8 times larger and to include the coordinate plane.